Okay, today we are starting vectors. It's actually the only day that you're going to learn new stuff about vectors. This unit will do vectors and then sequences and series. A lot of it you did in Algebra 2 with the sequences and series, but not the vector stuff. But vectors are particularly useful in physics, computer science, art, like if you're doing graphic design and stuff, you'll use those. But a vector, it's very similar to a matrix in terms of its operations, but we graph them a little bit differently, so I'll just show you what it is. So this beautiful graph. A vector just has an initial point, and then it has a terminal point. This arrow doesn't mean it goes on forever. It actually stops at that point. The arrow is letting you know which direction it is pointing in. So a vector can be described by two things, and we find those two things a lot. The first one is the magnitude, and that's the length of the vector. Okay, and then also the direction, and the direction is the angle from like the x-axis. So this one looks kind of like it would be about 15 degrees. So that is the angle. Cool, my protection has expired. Accept that risk. All right. So this is called the initial point. And then at the end we have the terminal point. Most of the time you will see vectors that have the initial point at the origin. That is what we see the most often. So I'm going to show you what that is. That's when our what's called component form, when the initial point is on the origin. Component form, the initial point is on the origin. So what we like to do is we like to take other vectors whose initial point are not on the origin and move them to where they are. So you can move them with their magnitude staying the same and their direction staying the same. We're just going to like scoot it. So if I took this one that I drew and just scooted it here, it would still be the same vector. It's just going to start somewhere else. So what we have to do is we have to figure out how to shift it from there to there. When we are talking about ordered pairs, how do we get this ordered pair and where is it going to go? We know that one's going to go to the origin. So this is how we figure it out. Figure out what our new vector is going to be. So when you have this, let's see. Oh, when you have component form vectors, they're going to be in brackets like that. Other vectors, we have ordered pairs for the initial and the terminal. But if you just see one with brackets, you're going to assume that it's in component form and the initial point is on the origin. So we're going to start out. I'll show you the equation real quick. So to find something in component form, the vector is subtract the x's and subtract the y's, and that's going to give us the component form of the vector if the vector's not, the initial point is not on the origin. All right, so I'll do one real quick. These aren't very hard to do. So let's say that we have initial is at 1, 2, and terminal is 5, 3. And we want to figure out what the component form of the vector is. I'm just going to sketch it and see what it looks like, see where these are. 1, 2, okay, so that's right there, and then 5, 1, 2, 3, 4, 5, 1, 2, 3. So this is what my vector looks like. So if I am going to find the component form, I will do terminal minus initial, terminal minus initial. So the x2 and the y2 are from the terminal point, x1, y1 from the initial point. So for us to find the component form of this vector, 5 minus 1 and 3 minus 2, which will be 4, 1. So if you plot the point 4, 1, you'll see that this is the same Oops, like I got it. This is the same length, and this is also the same angle of the vector, if I could draw anything to scale. So that's how we can find it, terminal minus initial to put it in component form. All right. And now we are going to find magnitude and direction. So magnitude is the length. And for this, we just have to think about making a right triangle. So we can do the one that we just had. If we had 4, 1, and we want to figure out what the magnitude is, I'm just going to sketch it. I'll do a low one like this. So 1, 2, 3, 4, 1. If I want to know what the length of this vector is, it's going to be the hypotenuse of a right triangle. So just drop my perpendicular down, make a right triangle. That's 4. That's 1. We're trying to figure out our magnitude. So magnitude squared is equal to 1 squared plus 4 squared, which is 17. So our magnitude is the square root of 17. I'm using m here, but most of the time for magnitude, it looks like they have absolute value bars around whatever vector this was. So this was vector v. So another way to say magnitude is this. So the magnitude of v is the square root of 17. Okay. So we could generalize what this formula would be. So if you call your component form a vector v, it's going to be a, b. Then if you want the magnitude, just the square root of a squared plus b squared, because that comes from your Pythagorean theorem. So a squared plus b squared, and take the square root, that's going to give you your magnitude. So if you just want to use that all the time, that is fine. That's our magnitude. Now we're going to find our direction. Direction will be the angle. So we'll do the exact same one again. That's just fun. 1, 2, 3, 4, 1. Okay. So we're going to use right triangles again for this. So let's say that's 4 and that's 1. The angle we are looking for is this angle right here. This is our theta. So we're just going to think about what trig function we would use. That's an opposite and an adjacent. So opposite and adjacent would be tangent. So tangent of theta is 1/4. So if I'm looking for an angle, remember we always have to do the inverse to find the angle. So inverse tangent of 1/4 is going to give us theta. So you can just do that in your calculator. Make sure you are in degree mode. So I'll switch to degree mode. I'll do inverse tangent 1/4. And that gave me 14.04 degrees. So that is the direction, 14.04 degrees. So if you're in the first quadrant, it will just give you the exact number. But if you're in any of the other quadrants, you're going to have to really pay attention to what it tells you. This is just like if we were solving equations and you had to think, oh, it's in the second quadrant, so I have to subtract from 180 or whatever else. Just think about the number that you get. If it's a negative, remember, if you're in the fourth quadrant, you'll get a negative, so you'll have to subtract whatever that number was from 360. So just make sure that you're paying attention to what quadrant it's in. So I always draw them just to see where it is before I pick that. Because especially since these are all going to be multiple choice, don't pick a number that you know is in the first quadrant if your vector's in the third. Okay. So that is your magnitude and your direction. Operations are very, very simple. You just do operations just like it was a matrix. You add and subtract things in the same spot. So operations, if I had vector u was like 2, 5, and vector v was like -1, 3, and I was asked to find u plus v, I just add the things together in the x position or the a position, and then also in the y position. So u plus v2 and -1 is 1. 5 plus 3 is 8. So the same thing goes with subtraction, also with scalar multiplication, and you can also do some combinations. If I'd like 5u plus 3v, I would just do 5 times the thing in u, so that's 10, 25, and 3 times the numbers in v, which is -3, 9, then add those together and get 734. Okay, so those are your operations. We've been writing things in component form. We can also write things in what's called linear combination form, and it's just a different way that vectors are described. Okay, and there are two unit vectors that are used for this. Unit means it's 1 unit long, so we can use a linear combination. So our I unit vector is the vector 1, 0. And the j vector is the vector 0, 1. So if I wanted to describe, say, 3, 5, I can write the vector 3, 5 as 3 times I plus 5 times j, because there are 3 that are in the x position, and that's what the I represents, and there are 5 that are in the y position, and that's what the j represents. So anytime that you have this, you just put an I next to the x value, a j next to the y value. So like -2, 4 is just going to be -2i plus 4j. Okay. We only have 2 things left, and we're done with this. I know I'm going by pretty quickly, but you can always rewind and watch it again if you need to see something or write it again. There are 2 ways that we quote-unquote multiply vectors. We have a dot product and a cross product. We're not going to do the cross product in pre-cal. You'll do that in physics or when you go to college and you do sciences and stuff. But we are going to do the dot product, and the dot product can tell us pretty easily if 2 vectors are perpendicular. So if you've got our first vector, let's say, we'll just name it x1 and not x2, x1, y1. And our second vector is x2, y2. The dot product is going to be a single number, and we'll get that, and we call it to dotted with each other. So u dotted with v is the product of x, both the x's, and you add that to the product of both of the y values. So you multiply your x's together, multiply your y's together, and add that together, and that's going to give you your dot product. And the dot product is useful because if it is 0, then the 2 vectors are perpendicular. And I'll write that in a second, but we'll do an example real quick. Say I have 4, -1, and make that u, and v is 2, 5. I want to dot u and v. 2 times 4 is 8, plus -1 times 5 is -5. 8 plus -5 is 3. So the dot product of u and v is 3. Okay. So I'll write down our statement to tell if 2 things are perpendicular. So another word that we use for perpendicular when we're talking about 2 vectors is the word orthogonal. You might have seen it before, I don't know, maybe in geometry. ortho, that root there means right. So perpendicular, orthogonal, we kind of use those interchangeably. So if two vectors are perpendicular, which means that they meet at 90-degree angles, or they would if their lines were extended, their dot product would be 0. So two vectors are orthogonal if their dot products are 0. So if you have two vectors and you want to see are they going to be perpendicular or orthogonal, you do their dot product. If it is 0, then yes, they are. Okay. To tell if two vectors are parallel, for them to be parallel, they're going to have the same slope. So if you're in component form, your slope is just your rise over your run, or your y over your x. So our slope with our vectors is just the y over the x. If you do y over x for both vectors and it matches, then you are going to have parallel vectors. Okay, so I'm going to check and see if two vectors, you'll see if they're parallel, perpendicular, or neither. Keeps jumping, sorry. Let's go with, let's say u is 6, 5, and v is negative 5, 6. I'll check for perpendicular first. U dotted with v, 6 times negative 5 is negative 30. 5 times 6 is 30. And when you add those together, you get 0, which means these two vectors are orthogonal, or you might say perpendicular. Okay? Obviously, if they're perpendicular, they're not also parallel, but if you want to check for parallel, we do y over x, 5/6, y over x, negative 6/5, and those aren't the same numbers. And our very last thing is if we want to find the angle between two vectors, so if you've got like a vector here and a vector here, and you want to figure out this angle that's between those two, you could find the magnitude of the first one and the magnitude of the second one and subtract them. That works as well, but there's also a nifty little formula that you can use. I kind of like it, it's pretty quick. So here is our formula. You would going to do the inverse cosine of u dotted with v divided by the magnitude of u and the magnitude of v. Magnitude of u times v. So we'll just do a quick one. Let's say that u is 1, 4 and v is negative 3, 2. I've got to find the magnitude of u, the magnitude of v, and also the dot product. Then I'll just plug it into the calculator. So the magnitude of u is the square root of 1 squared plus 4 squared, which is the square root of 17. The magnitude of v is the square root of negative 3 squared plus 2 squared. Make sure if it's a negative, you put it in parentheses. It's at 9 plus 4, so that's going to be the square root of 13. Okay, and I'll also do u dotted with v. 1 times negative 3 plus 4 times 2, and that is 5. So I've got u dotted with a v, magnitude of u, and the magnitude of v. So I'll plug it into my equation. Inverse cosine, 5 over the square root of 17 times the square root of 13. Okay. Go away. So make sure that you are, if you're putting this in the calculator, do the fraction mode, or if you're not, you're doing the divide by signs, you'll put parentheses around the bottom part. So I'm going to go ahead and type that in. Inverse cosine 5 divided by the square root of 17 times, insert another parenthesis, times the square root of 13. And it gave me 70.346. So my theta is 70.346 degrees. Okay, so that's all for vectors today. Yeah, if you have any questions, just let me know and I'll help you out.